Hello and welcome to this lecture about basics of production planning. This lecture is part of the course Mine Design and Mining Economy, and my name is Sohail Manzoor. I'm a PhD student at Luleå University of Technology, Sweden. This lecture summarizes some of the production planning activities involved in the mining process. First of all, what is a production plan? A production plan for a mining enterprise is a document based on which the rate of extraction is determined, that is the amount of useful resources acquired over a unit of time, extracted over a unit of time. And that unit of time can be an hour, a day, a month, or a year, or it can be a whole mine life. And due to this, it is a basis for conducting and accounting for the mining activity. Production planning is also called extraction planning sometimes. The basic objectives or goals of production planning are to mine the ore body in such a way that for each year the cost of production is minimum, to maintain operation feasibility within the plan, to deal with the uncertainty of getting ore so that the possibility of misestimation of ore tonnages and grades in the reserve model can be countered, to minimize or defer waste removal requirements as much as possible, to develop a logical and easily achievable startup schedule with due recognition to manpower training, pioneering activities, equipment deployment, infrastructure, and logistical support, to maximize the ore extraction while minimizing the risk of potential structure failures, to properly examine the economic merits of alternative ore grade, ore production rate, and cutoff grade scenarios, and to thoroughly subject the proposed mining strategy, equipment selection, and mine development plan to what if possibilities before a commitment to proceed is made. Planning is obviously an ongoing activity throughout the life of the mine. There are two kinds of production planning which correspond to different time spans. First one is operational or short-term production planning, which is necessary for the function of an operating mine. And the other one is long-term production planning, which is usually done for feasibility or budget studies. It is it supplements the design and reserve estimation work and is an important element in the decision-making process. Long-term planning tools allow mine planners to first set mine targets and then test scenarios to find the best way to mine over multiple working periods. There are some planning rules, especially for long-term planning, that should be kept in mind by planning engineers. The first one is we must keep our objectives clearly defined while realizing that we are dealing with estimates of grade, projections of geology, and guesses about economics. We must be open to change. Second one is we must communicate. Third one is we must remember that we are dealing with volumes of earth that must be moved in sequence. So everything goes in a sequence. It's not like something is very high grade and you just go and mine that out. Maybe you need to mine something else first and then you are able to reach that high grade ore and mine that out. We must remember that we are dealing with time. We have the time constraints. And we must seek acceptance of our plans such that they become the company's goals and not just the planner's ideas. Over the years, Taylor has provided some very practical and useful advice regarding mine life. Mine life is directly linked to the extraction rate for a given ore deposit. If we have too low production rate, it will sacrifice possible economies of the scale and it will defer possible profits too far into the future. Similarly, on the other hand, if we have too high production rate, it may drive up the project's capital cost beyond any ability to repay within the shortened life of the mine. The output of too high production rate may be unsaleable as well as too short mine life for a large enterprise may be wholly undesirable on social ground. Taylor, on the basis of his studies about different projects, different mining projects and different deposits, he developed an equation to estimate the life of the mine, which is the life of mine in years is directly proportional to the fourth root of the expected ore tonnage. And if we have the ore tonnage calculated or expected, we can estimate the life of the mine, and it gives a fairly uh, enough accurate estimate of the life of the mine. The cash flow calculations are usually divided into two periods for the whole mine life. First one is pre-production period and the other one is the production period. However, nowadays there is generally a third period which is known as the post-production or closure period in which final reclamation takes place, but that is not covered in this lecture. The pre-production period can be subdivided into three different and distinct expenditure categories, which include the detailed exploration, property acquisition, and infrastructure and mine development. The basic line items in the pre-production cash flow calculations are briefly discussed here. The first item describes which year of the project it is. For example, first year, second year, third year, and so on. Second item shows the calendar year, for example, 2016, 17, 18, and so on. Third item is the details of the capital expenditures, which include a variety of different capital expenditures, for example, amount spent for property acquisition, royalties, exploration, development, mine and mill buildings, and mine and mill equipment, property tax, and the working capital, which represents the amount of money necessary to cover the operating costs during a portion of the project's life. Next item in the list is the total expenditures that sums up the capital expenditures for every year. Next item is the details of the cash generated due to the tax savings. For example, if this mining project is one of the projects for a large mining company, or the mining company working on this project is one division of a large profitable corporation, the corporate structure enables the company to generate tax savings during the pre-production period. To clear this concept, we have a simple calculation here. For example, the corporation or the income, for example, the corporation profit or the income without considering this mining project for the year is $10 million and the tax rate is 40%. So the corporation will pay a tax amount of $4 million for that year. However, if we consider the mining project as well and subtract the cost, for example, of exploration, which is $1.5 million, for example, the corporation's profit, which is taxable, will be $8.5 million, and the payable tax amount will be $3.4 million instead of $4 million, which was when we didn't include this mining project. Hence, the mining saved an amount of $0.6 million, which is called as tax savings. Similar tax savings occur with regard to development, depreciation, and property tax when they are applied against other income. Next item in The list is total cash generated, that sums up all the cash generated due to tax savings for each year. And the last item is the net cash flow, that subtracts the total capital expenditures from the total cash generated. This is the net cash flow, which is negative for pre-production period. The basic line items in the production period cash flow calculations include the production year, project year, calendar year, revenue, royalty, net revenue, mining cost, processing cost, general and administrative cost, property tax, severance tax, depreciation, state income tax, net income after cost, depletion, taxable income, federal income tax, profit, depreciation and depletion, which is already calculated in the expenses. Now it will be added to the profit, the cash flows, and the capital expenditures, the working capital, and the net cash flow. So all of these calculations are done to come up with the net cash flow for the mining operation. To select the best option for the mine and mill plant size, following steps are usually performed. The first one is the metal content of the block together with forecasted sales price and estimated full-scale plant metallurgical recoveries are used for determining the revenue. Production costs through to sales and shipping costs are estimated. A net value is calculated for each block. A block with a net value equal to 0 is one where the revenue is equal to the production cost. The grade corresponds to a mining cutoff. A computer technique is used to identify all blocks capable of paying for the cost of uncovering them. These are included within the final mine limits. A mineral inventory, which is an ore reserve, is constructed. Milling and mining rates are assumed and the associated capital cost determined. For example, a series of different milling cutoff grades might be applied to the total pool of material. Mill ore quantities would be calculated, and these reserves would be used to size the mill plant. A financial analysis would be conducted for each alternative to determine the net present value, internal rate of return, or it can be any other economic consideration as well. The best option would be selected after performing all these steps. The cutoff grade is the criterion which is normally used in mining to discriminate between ore and waste in the body of a deposit. Waste may either be left in place or sent to waste dumps. Ore is sent to the treatment plant for further processing and eventual sale. The choice of cutoff grade can directly affect profits. A mineral extraction process is considered to consist of three stages, which is mining, concentrating, and refining. Each stage has its own associated cost and a limiting capacity. K.F. Lane presented some basic equations to determine the profit and cutoff grades for any deposit. The profit equation is derived from the simplest profit equation, that is, profit is revenue minus cost. Here, P is the profit, while this part here, S minus R multiplied by QR, is the revenue, while the rest of the equation is the cost, different cost involved in the mining process. M is the mining cost per unit material excavated. C is the concentrating cost per material milled, and R is the cost per unit refined and sold. Similarly, QM is the total material mined, QC is the total material sent to concentrator, and QR is the material sent to refinery and ultimately sold. S is the sales price of the product. F is the fixed cost, and the T is the production duration. For the calculation of this profit, for example, it can be 1 month or 1 year, etc. If the purpose is to maximize the profit and the limiting constraint is mining operation, the cutoff grade is given as this equation where this Y is the recovery. For example, if we have 100% mineral recovered from the ore, Y will be 1. Similarly, if the limiting condition is concentrating capacity, the cutoff grade equation becomes this one, where we have a new parameter, this capital C, which is concentrating capacity. And if the limiting condition is refining capacity, the cutoff grade equation becomes this one, where we have this new parameter capital R, which represents the refining capacity. Similarly, if we want to maximize the net present value of the operation, the equations for cutoff grade are slightly changed, and we have two new parameters here, D and V, where this D is the discount rate and V is the net present value of the remaining profit. The cutoff values change with time, mining progress, etc. It is simply a grade which is used to assign a destination label to a block of material. Where should it go? It should go to dump, it should go to my mill. So it assigns a destination label to a block of material. Short-term planning starts when the long-term plan is ready. This is where the detailed design of the mine takes place and the plan is implemented on routine production level. It defines the intermediate steps required to find the solution for routine activities under physical, operating, and legal constraints. It provides the expected profit information necessary for future production estimates and market demands. Short-term plan provides an annual mining program that normally includes daily production rate, materials handling plan, equipment and resource allocation, and workforce requirements. Short-term planning dealing with hourly, daily, and weekly production plans is also termed as production scheduling as well. Scheduling is a very important part of the mining process. Different scheduling scenarios must be considered to see the effect of extracting different amounts of ore and waste in different times from different locations on the net present value. And then the best one should be selected for operation. Daily production scheduling helps to have better control of the ore grade. It helps to make an effective use of the available resources. Daily production schedule makes sure that weekly or the monthly production schedule makes sure that the daily production is aligned with the monthly production schedule, while the monthly production schedule ensures that the maximum utilization of resources within the given constraints, such as the allowable grade variability, and it controls the long-term variability of the ore production as well. There are some parameters that must be considered for production scheduling. Production scheduling should include the mining locations, not just the tonnage. Production scheduling cannot be done independently of hauling, blending, processing, etc. It is we need simultaneous optimization. And then long-term considerations should guide short-term production scheduling, and ultimate mine design and cutoff grades should result from these long-term considerations. Once the production schedules have been developed, equipment fleet requirements can be examined. Dump planning is also a part of mine planner's job that depends on a number of factors. For example, length of hauls, the required lifts, the relationship between dumps and property constraints, other installations, drainage, etc., and the reclamation and environmental requirements. Dump planning can significantly influence mine planning, particularly in the haulage layout, scheduling, and equipment requirements. Here, I will conclude this lecture. Hope it helped you to understand the basics of the production planning. Have a nice time. Thank you so much.